Okay, good morning, guys. Today is day 12 of taking grade 11 functions in the summertime in July. Wow, we're almost done because it's day 12. That means we have literally 7 more days. Wow, you guys made it. Some of you guys. I know it wasn't easy. No one thought it was going to be easy, right? The intensity of the 5 months into 19, let's say not even 19 days, 18 days, maybe not even 18, 17 days. So this is what it is. Okay, so let's start with land acknowledgements. We acknowledge we are hosted on the lands of Mississauga of the Anishinaabe and the Haudenosaunee Confederacy and the Wendat. We also recognizing enduring presence of all First Nations, Métis, and Inuit people. Okay, so let's get down to business. We are starting a new unit. Okay, unit 5, discrete functions. We're going to be doing all this things today. And then there is a quiz. I don't know why it says Tuesday. Today's Wednesday, my bad. Let me change that because someone's going to like look at it and say, wait a minute, what's going on? So let me just change that. But it's actually today. Okay. Let's get rid of the Tuesday. Today's the 19th anyways. Okay. And your test, your unit 4 test, it says it's due today, but I'm extending it till Thursday. Okay. I told you guys that yesterday, right? So if I go under assignments, let's double check from your guys' point of view, right? It says here due today, but looks like only 3 people handed it in, or whatever, 4 people. You guys got to make sure because I cannot extend it past tomorrow. So work on it as if today is the due date, because it says here it's due today. But I'm going to give you till tomorrow. But make sure you don't ask me anything past tomorrow because we got to keep going. Remember, like the classes are going quick, so you got to get things done when they're due. So it's due today. Work on it today as if it's today. If you can't get it done today for whatever reason, you have some kind of problem, some kind of internet issues, it's due tomorrow. I mean, you'll have extended to tomorrow, but it's actually due today. So please don't come back to me on the 20th and say, can I have an extra time? I already gave extra time because based on the course outline, it's due today. Okay. So now let us go to content, because what is this? Discrete functions. What is that all about? Interesting. Okay, so just go to here. Maybe let's look at it from a student point of view. I want to make sure you guys can see it. So let me go here. So you guys can see. So there you go, unit 5. Well, actually, it's discrete functions, so it'd be here. So lesson 1, lesson 2. All these things are in the way. Do you need to know these things? Yeah, you do. Oh, actually, shoot, I don't have the worksheets in here. I have to put the worksheets in here, but let's just go through the lesson. So we're gonna learn lesson 1 and lesson 2 and lesson 3. These are the 3 lessons we're gonna go through today. If we have time, otherwise, yeah, let's just get as much as we can. I might have to shorten some lessons. There's no video for this, so we're gonna go through it. But I have to say that the lesson itself is pretty straightforward. Okay, so what we're gonna learn is arithmetic and geometric sequences. So basically we're talking about sequences. There's 2 types of sequences, right? So at the beginning, how much can you figure out by looking at these list of numbers? right? How can you figure out, what can you see when you look at these list of numbers? This is a question I'm asking you guys. You go 1, then 2, then 3, then 5, and 8, and 13. Is there a pattern? Do you see something? Does anyone can tell me if they see a pattern? Anyone? No? Okay, it's fine. So I look at, when I see this one here, okay, 1 plus 0 gives me 1. And then if I go from here, because I mean, before that was 0. And if I go from here to here, 1 plus 1 gives me 2. And if I go from here, 2 plus 1 gives me 3. If I go from here, 2 or 3 plus 2 gives me 5. And then 5 plus 3 gives me 8. So you can see there's a pattern, right? 8 plus 5 gives me 13. And then 13 plus 8 gives me, so there's a pattern here. There's a pattern, right? That's what's happening here. So we're trying to figure out patterns. And then basically once we figure out, we see there's a pattern, how can we turn that pattern into a formula, right? Because there is a formula for that. And that's what we're trying to do here, okay? Turning patterns into formulas, okay? So let's see, let's look at the definitions first. A formula that represents any term in a sequence relative to the term number. Okay, let's see if we understand that. A formula that represents any term in a sequence relative to the term number. Okay, that's a little bit interesting. We have to see what we actually mean by that. And then sequence an order list of numbers identified by a pattern or rule that may stop at some number of continued indefinitely. Okay, so we get sequence. It's some order list that's identified by some pattern. Okay, and formula of a general term basically means coming up with the formula for the sequence, I believe. So here's examples of a list, and this list here, it ends here, right? It's not going forever. But then list here may go on forever because you have ... So that means it continues forever. Okay. Okay. Note the terms of a sequence represented by the range of the function. Let's get into an example so we understand what's going on here. So write the first 3 terms of each sequence given the explicit formula for the nth term of the sequence. Okay, so here is a formula. So write a formula, but we're given a formula here. And what we're looking at here, let me just highlight because some of this stuff is, we have to break it down. So this means what term? So when I go like this, 1, 2, 3, or actually, no, let me use different numbers because that may be a little bit confusing. If I go 13, then 17, and then I don't know, 20. Okay, these are terms, right? That's term 1, term 2, term 3, right? And when we're talking about terms, this would be my 10th, my 3rd term. So we'd call it term 3. This would be my 2nd term. So we call it the 2nd term, T2. And then this would be my 1st term, okay? Right, so that's what we're saying by term. So when we look at these questions here, that's the 1st term, because you got that. This is the 2nd term. This is the 3rd term. So the first 3, so it shows at the bottom there. Get this out of the way. Right, it shows in the bottom that the first 3 terms are 2, let me clear the screen a little bit, 2, 11, and 26. Okay, based on this formula that we're given. Okay, Now we are given this formula here, right? And as a result of being given this formula, here are our terms: term 1, term 2, term 3, right? So we're going to get into examples that make sense more, because you're wondering where did this formula come from? Where did this formula come from? Well, you're going to be given that formula at some point. Okay, you'll be given that formula, and we're going to figure out what how we can use that formula to figure out sequences. Okay, so here are examples of sequences, arithmetic sequences. And we're saying arithmetic because it's basically in between the terms, between term 1, term 2, term 3, term 4, and go on forever. It's an increase of 4. Okay. And then maybe going this way, part B, going from this term to this term, you're going down by 4. So that's the sequence. So arithmetic sequence, these are called arithmetic sequence because they are increased or decreased by a constant number. So it's going down, it's going up by a constant number, plus or minus. Okay. And the general formula for arithmetic sequences is this. Okay. So this is the general formula. Okay. And this formula, obviously, you're going to use this formula to calculate, basically what term. If I want to find out maybe the 20th term of a sequence, I would write T20, and then I would have to figure out what these variables are. So let's look at what these variables are. A is the first term. N is the term number. So the term number is 20, because we're looking for the 20th term. So we put N as 20, because that's what would be there, 20 for T20. And then -1, and then D would be the common difference. What is the difference? When we say common difference, is it +4 between each term? Is it -4 between each term? So that would be the difference that you're going to be putting inside there. And then obviously we said that here the term sequence, a term in the sequence. Okay, so we have to see examples of this. Let's scroll down. Here's an example. Okay. Determine a formula for the general term of the following arithmetic sequence. So we want to figure out the general formula. Okay, so we are given a general formula from here, but we want to fill in the blanks for it to be a general formula for this particular sequence. For this particular sequence, okay, the general formula, we start off with the general formula that we know, and then we fill in what would be the general formula for this particular sequence. So what you want to know is, what's my D? My D is what's the difference between each term? Is it, is it a +4, +5, or -3, or -2, right? And then what is the first term? A is the first term. So first term is A, and then the difference is +4. Okay, so now we plug it into there. We have A, and then we have +4, and that becomes my general formula for this. Now, once I get the general formula, the question is, say, what is the value of the 30th term? Okay, so the value of the 30th term, I just use the formula which I calculated above, and basically I use this formula to calculate what's the 30th term, and you can see T30. So what do you put in there? 14 plus N is 30, because we're talking about the 30th term. So now your 30th term, if you were to keep going all the way to 30, to 30 terms, you would be at 130. Okay. So that's what we'd be doing there. I think this is kind of simple. You guys can see that, right? It's not as hard as the other things we've been doing. Okay. And now here it says here, determine the general formula for this sequence. Okay, so for this sequence, you're going from 7, 3, -4, -1, -5. So the difference between each term is -4. Okay, and my first term is 7. So when I plug it into this general formula, it turns out to be this. So this becomes a general formula for this sequence. And then the following question says, what is my 41st term? My 41st term, if I were to keep on going on this sequence, it would equal to, based on this formula, it would equal to -153. It would have to be minus because I start going minus here, right? So these clues would be that if I'm going minus, that means my 41st term has to be in the minus. If you plug in plus, then you know obviously it's wrong because it has to be a minus. Okay, now we're going to look at geometric sequences. So if arithmetic sequences dealt with plus or minus between each term, geometric sequences deal with multiplication or division between each term. So if I'm looking at, well, actually, we don't do division. It's always going to be, maybe if we're not multiplying by a whole number, we're multiplying by a fraction. Okay, so a fraction looks like it's division, but it's actually multiplying by a fraction. Okay, so between each term here, I'm multiplying by 3. Okay, and between each term here, yes, I can say I'm dividing by 2, but no, we don't use that. We say we're multiplying by a half. So we're multiplying by a half, it's going down by half between each term. So these are called geometric sequences because the ratio of the consecutive terms is constant. So the ratio is constant, meaning the multiple from each term is constant, right? So ratio is a fraction. So if we can say that, if we can look at it another way, the ratio between each term is constant. So really and truly, here we're multiplying by a half, but this one here, we're multiplying by 3, but it's actually 3/1, because now we can say that 3/1 is a fraction, and fractions are ratios. So between each term, the ratio is consistent, is constant between each term. Okay, that's why we say ratio, because ratio is a fraction. So the fraction between each term is constant. Even though we can say, well, is this 3 as a fraction? Yeah, it is. 3/1 is a fraction. Even though we wouldn't say it as a fraction, we just say it's 3. Okay. So now we're gonna go down and look at examples of that. So here would be the general formula that you would get for using geometric sequences. Okay, so we know that Tn is the term in the sequence that we're looking at. A, it's the same thing. A is the first term. We always know that from the previous one. R is the ratio, is the ratio that we're looking at. Okay, and N is the term number. So, like we said here, there's no division. You're not dividing by 2, you're multiplying by a half. Okay, so what is so now we use this to figure out the general formula for the particular sequence we're looking at. So here's a particular sequence we're looking at. Here we got 2, 6, 18, 54, 162. Okay, so now here's the general formula we have from above. Now we want to figure out the general formula for this particular sequence. Our first term is 2. Our ratio between each one, R, it means ratio, is 3, which means 3/1. So our general formula for this sequence would be Tn is equal to 2 bracket 3 to the power of n minus 1. Now, if we want to look at the 9th term, Well, I'm going to plug in here 9 over there, and then that's would be the value of my 9th term, 13,122, right? Because it makes sense. It's getting bigger by a 3, so at some point it's going to be like a big number. Okay. Okay, so we're getting the hang of this. So here is another one. You can say you're dividing by 3, but we don't say that, right? We're multiplying by a third. So it's going down by a third because we multiply by a third. Okay, so now we want to find that formula for this sequence. And for this sequence, our first number, A, is 270. Our ratio is 1 over 3. So here's our formula. And now we want to find the 9th term. Well, we plug in into this formula, n is 9, and we figure out our 9th term is going to be a fraction, which makes sense, a really small fraction, because we're getting really small here, right? Right? Really small, because we're going down by a third. So yeah, it would make sense this would be a fraction. Okay, so that is that for geometric and arithmetic sequences. Okay, so now we're going to come out of this and we're going to look at series. And again, I didn't put, I'm going to put the worksheets in here. That way you guys can practice. Okay, so here we're going to talk about arithmetic and geometric series. Okay, so let's go like that. Okay, arithmetic and geometric series. So definitions. Okay, we're going to find the formula for the general term that represents any term in a sequence relative to the term number. Sequence, because that's what we're talking about. We talked about before what sequence was. So this is just from the previous lesson. We know what sequence is, and we know what arithmetic sequence, where between each number it goes up or down by a certain number, and in geometric sequence it goes up or down by a multiple. Okay, so series is different. So series is the sum of the terms of the sequence. Okay, so the sum of the terms in a sequence. So if I want to know the sum of the first 3 terms, there's a formula I can use to figure that out, right? So, and so we're looking at S now as our series letter that we're looking at. So find S4 of the sequence represented by this. So what we're saying here, find the sum of the first 4 terms, okay, of a sequence. So S4, the first 4 terms would be our first term plus our second term plus our third term plus a 4th term. So we're looking at the sum of these 4 terms. Okay, that's what we mean by, and we're looking at the first 4 terms. Okay, saying the first 4 terms. So here it is. So now we got to figure out, first of all, if this is the formula for the sequence, we need to figure out what are the 4 terms. What are the value of the 4 of each term? Okay, so here is term 1. That's what it's equal to when you use this formula. And then term 2, and then term 3, and then term 4. So then that means our sum of all those terms is equal to that. Okay. So we can also have a general formula for that, because maybe we don't need to have this here. Here, you know, this is the formula for a particular sequence. But if you're not given that, you can still use a general formula to figure out what is the series of a particular sequence. So here's a general formula. Okay, so now you can, you know, use this formula, and then here we know what this formula is for the arithmetic sequence. This is a general formula for that, right? We know that. So if you were to plug that into here, you could write this as your formula. So your formula could be either this or this, right? Because we know the formula for arithmetic series is like this. And if I were to plug this into here, you can see I have 2 and I have a plus n minus 1, right? So I can actually put that in there and maybe write it like this, right? But these two, you can use either way, this formula or this formula, right? If you have the first term and the n term that you want to figure out, you can use this formula, right? Or you can use this formula if you already know the beginning term and you know the term of the last term. Okay, so it says here, use this version when given the value of the last term of the series, right? So for example, our first term is what? A. We're given A, this is our first term, and maybe our last term would be T30. So that's the 30th term. So you can put here the 30th term plus the first term and use this here to figure out what is the series, what's the sum, I guess, for the from term 1 to term 30. You can use this formula. Okay. So we have to look at examples. This is just the formulas that we got to see that how it works in a particular example. So here, for this series, we got 1 plus 3 plus 5 plus 7, right? So we're adding all these terms together, and we need to figure out what's the sum of 23 terms. Okay, so here's a general formula that we have, and we want to figure out the sum of 23 terms. So our A is 1. Okay, our D is the difference between each term. We know that each term is going up by 2. And our N is our 23rd term. So we can plug it in here as 23. So the sum of the 23 terms, that's what we're saying here. The sum of 23 terms is going to equal to 529. The sum of these terms, the sum of these 23 terms, remember this is dot, dot, dot. That means it can go on forever. But we don't want the forever, we want only 23 terms. So the sum of 23 terms equals to 529. You plug it in here, you get your sum. Okay. Here is another example question. Arithmetic. I don't know why I can't say that word. An arithmetic series with 52 terms. With 52 terms, starts with at -7 and ends at 102. Okay, so it starts at -7 and ends at 102. And in between we have 52 terms. So find the sum of this series. So we have the things we need. We have n, which is all the terms. We know the last term. Okay, at T52, our last term is 102. Our first term is -7. So now we can just plug it into here in this equation. Remember I was saying about this equation here? Either your first term, your last term, and the term number. Okay, that's it. Quick and easy. You can figure out the sum of 52 terms in this question. Okay, so that was just for arithmetic, and arithmetic because is dealing with sequences that are going up by plus or minus, right? This number went up by 2, constant. Okay, now we're dealing with geometric, where the sequence goes up by a multiple. Okay, so here's a general formula for the sum of a geometric sequence. Okay, so here's the formula. So the same kind of thing. when you look at this geometric sequence, this one is going up by a multiple of -2, okay? So it's going up by a multiple of -2. Okay, so you know this is a geometric sequence because it's not an arithmetic sequence, it's a multiple. So now we want to find S. We want to find the sum of 5 terms in this sequence. Okay, so here's our formula. In this sequence, A would be -1, and the ratio is the multiple between each term. You know, each term is going up by -2, so R would be -2. Okay, so now if I plug it into this formula here, I want to find the sum of 5 terms. I mean, you can also just write it out because here you got 1, 2, 3, 4, 5. So there's 5 terms. You could just write it out if it's like this and just add them together. Okay. But what if you this says here ... Well, now what if I need 13 terms, right? The sum of 13 terms. Well, if I need the sum of 13 terms, now I'm gonna have to use that formula. I can't just add it here because I don't have all the terms set out here. So I'll use this formula. We know A is our first term and R is the ratio between each term, which we say is -2. So we use this formula here and then you can figure out the sum of 13 terms of this sequence, right? And it equals to, that's the sum of 13 terms. -2731, okay? So now we're gonna go over to here. A student, maybe this is more of a problem question that makes sense for us. A student is offered a job with a math teacher that will last 20 hours. It pays $4.75 for the first hour, $5 for the second hour, and $5.25 for the next hour, and so on. So each hour is going up. Now, is this sequence a multiple sequence? Meaning, is it a series sequence or is this a arithmetic sequence? Let's see, anyone can tell me in the chat if you're paying attention. Is this, the first one is $4.75, $5, $5.25. Is this an arithmetic sequence or is this a series sequence? Sorry, is this a geometric sequence? That's what I meant to say. Anyone paying attention can tell me? Let's see who's saying that. Arithmetic, yes, you guys are right? Because the difference between each term looks like it's 25 cents. Okay, so you can see here our first term is A. Our second, our difference between each term is 25 cents. And it says here, you know, this will last for 20 hours. So we want to figure out what is, and basically can figure out how much money total you'll have after 20 hours. Okay, right? So after 20 hours, that would be like basically the sum of the 20 hours. So we want to find the sum of the 20 hours because that will be his pay. So you can use this formula here. N is 20. A we know is $4.75, and the difference between each one is 25 cents. So you do this. So therefore, the sum of this guy working for 20 hours is $142.50. All right, so that's a question that you can get. Okay, so it looks like we are done with that. Okay. Let's go into lesson 3. Recursive functions. Let's go into that. Okay. Recursive functions. Okay. So recursive formula, a formula by which each term of a sequence is generated from the preceding term or terms. Okay. So recursive formula. So we got to see what that looks like because we just read that. What does that look like? So recursive functions that get new terms in the sequence by using earlier terms. Okay, we know what terms are. N would be the term, and the term before that would be n minus 1. Okay, so that's what we're looking at. So now let's look at this example here. Write the first 4 terms of the sequence. Well, t1 equals to t n minus 1. Okay, so this would be I guess a little bit of the general formula. And t1 starts at 7. So here we want to find the first 4 terms, and the first 4 terms using this formula here, we're given this formula. What is the first 4 terms? Well, and we say t1 starts at 7. So if t1 starts at 7, so we plug in here our first term. So we want t2. So t2 is going to equal to, or which is our second term, is going to equal to our first term minus 2. Right? Our first term is t1, right? Because we're going down by 1 term, the previous term. So that means our second term is going to be 5. Then we go here, try to figure out what our third term is. Our third term is made from the first term, or is made by the previous term minus 2. So that means here our third term is going to be, well, 5 minus 2 is 3. Now our third term is 3. So now we want to figure out what our fourth term is. So our fourth term is made up of our third term minus 2. So therefore it's going to be 3 minus 2. So all our terms, right, from the first 4 terms would be 7, 5, 3, and 1. Because we're given this formula, and we're saying here our first term is 7. So based on that, what is our values of our first 4 terms? And that's what we just calculated. Okay, now this question here, same sort of thing. Our first term is 5, and it's saying here, calculate the first 4 terms. So based on this formula, what are the first 4 terms of this sequence that this formula that creates a sequence? So we're saying that our first term is going to be, we already know it's 5. So what's our second term? Our second term is going to be, plug it into this equation here. We have 2 times 5 plus 4. That means our second term is 14. Then we need to figure out our third term. Our third term is going to be, using this formula, 2 times 14 plus 4. That means our third term is 32. Now we want to figure out what is our fourth term. I'll plug in the 32 in there. 2 times 32 plus 4 is 68. That means our fourth term is 68. So our first 4 terms are 5, 17, 32, and 68. Okay. So again, this is just saying find the first 4 terms. We also see questions asked in function notation. That's fine. So meaning it may look like this. This is function notation, because here we didn't do it in function notation. We just put it as t n, right? But it may be given to you as function notation. So f of n, right, which is any term we're trying to figure out. And here's the formula, where our f of 1, which is our first term, is equal to this. So if our first term is equal to 2, that means our f of 2, which is our second term, is going to equal to this based on this formula. So now we're looking at this as a function, right? Our function of of all our terms is this, right? And that's basically how you figure out. So this stuff here would be given, right? Because you can't figure this out. You'd be given this. And then from there, you have to figure out what the question is saying. The question is saying, what's the first 4 terms? Well, first term is, I know, is 2. That's given it to me. So I can figure out my second term, my f of 2, my f of 3, and my f of 4. Okay. So that's the first 4 terms of the sequence. Now saying, what's the first 7 terms of a particular sequence? here's the formula we're given of this sequence. We want to figure out the first 7 terms, where T1 is 1 and T2 is 1. Okay. Okay, that's a little bit confusing. T1 is 1 and then T2 is 1. Okay, then here, what is our T3? Well, our T3 is basically the RT2. Okay. This is the formula here. So it would be our n minus 2. That means it would be our first term plus our second term. Okay, first term minus second term. Our first term plus second term. So here you have 2. So that means our T4, which is our fourth term, is going to equal to our second term plus our third term. It's equal to 5. Our T5 is equal to our third term plus our fourth term. It's equal to 5. Okay. So in this case here, each term is this in the sequence is the sum of the previous 2 terms. Okay. So each term of the sequence is the sum of the previous 2 terms. So you have 1, 1, 2, 3, 5, 8, and 13. So write a recursive formula for each sequence. Okay. You gotta look for a pattern. So between each one of these, right, it's multiplying by minus 2. Okay. So here would be our formula for this. Tn is equal to minus 2 times the previous term. Okay. So our first term, to get to our second term, we need to multiply our previous term by minus 2. Okay. So we start off at -3 in this question here. And then you can see our second term is a multiple of our first term times -2. Our third term is our second term times -2. Our fourth term is basically our third term times -2. So you see there's a pattern there. Right? And now this is showing if we were to graph it, you can see there's a pattern. Right? This is whatever term, our term number, and then this is the term value. Okay, so if you're looking at graphing it, what's our term number? Our term number is independent of our term value. So or we can say our term value is dependent on our term number. Okay, remember this is always, y is always the dependent. It's dependent on x. Okay. So looking at this one here, multiplying each term, the multiple for each term is +4. So it's going to be, the formula would be our Tn is equal to our Tn minus 1 plus 4. Okay. So this one would be, now this one is a little bit different. Right? You can see it's actually going up. It's increasing by 1. So this one's a little bit different. So we're looking at from each term, it's increasing by 1. Okay, what does that mean? A first term. Actually, what am I saying? I'm saying something that doesn't make any sense. Sorry, my bad. So from this term to this term, it's going up by 2. From this term to this term, it's going up by 3. From this term to this term, it went up by 4. Okay, my bad. So now you're looking at, for the formula for this would be our first term. Okay, our first term, or basically this is our first term, but our second term is equal to our first term plus n. Now that is the part that was a little bit tricky there, right? Because I need to make that clear. right? This represents our term number. We're adding a term number. So this is our fourth term. This was our third term. So this is a little bit tricky, right? This is the way to explain this one. This is our third, and this one was our second, right? So each of these went up by the term number. So if I'm looking at eight, right? So term, my bad. Term, whatever, this would be term 3. So term 3 is equal to, let's look at that a little bit. Let's look at better. Term 4, which is the last one. Term 4 is equal to my third term. So this would be T3 plus my fourth term. So that would be, since it's fourth term, is plus 4. Our T3 is 8. The value of our third term is 8. And then we're going to add the number 4 because we're talking about the fourth term, right? That's a little bit confusing. I think we need to see an example, but that's sort of what this sequence was doing. It's sort of a little bit of a mouthful to explain. Okay. I think that is it. I think I got to give you examples. Let me pull up. So give me a second. I'm going to put, because we're done those, I want to put the worksheet in there, and I want to go through a couple worksheet questions, okay? So I feel like if I don't, you guys will get confused, okay? So give me a second. I want to close my camera, but don't go nowhere, guys. I didn't say, some people are probably going because they weren't listening, so they think it's over. So I didn't say it's over yet, okay? I'm putting, like I said, I'm putting the worksheets in there. So don't go and don't ask me anything in the chat while I'm doing this. I can't do two things at once. Hold on. Okay, let's see if it's there now. Yeah, it's there. Just gotta change the dates. Okay, so let's go like that. Okay, so let me just share my screen. Okay, so I put the worksheets there. Okay, so again, you can figure out what the general formula is. You can go get that. This is where you need the general formula to help you answer these questions. Okay, so this will prepare you, and here are the answers here. Right, so there's 3 worksheets. Again, you know the worksheets don't count for marks. Okay, so don't think that they count for marks. It's just for help you practice. But there is a quiz. There is a quiz for this, for the sequence, the series, and the recursive functions. Okay, there is a quiz that is 10 questions. Okay, and you get two attempts to it. Okay, so I would say go through these questions and then try the quiz. But again, what is the ultimate thing that's due today? Let me go back and close this. Let me close this. The ultimate thing that's due today is, going back to home page, it is your unit 4. Okay, your unit 4. And I say here the latest is actually due today, but the latest is tomorrow at midnight or before midnight. Okay, so all these things we just talked about today, and there is a quiz, and I think you guys can see it. It's the July, where is it? This one here, July 19th. Today's July 19th. Okay, so that's the quiz. And again, it is due today, but you know, I always give you guys an extra grace period for that. So that is it for today, guys. Okay, so just keep working away. Some of you guys maybe weren't happy with your midterm marks. Don't miss anything. Do everything by the due dates. It is what it is in life. Life happens in the real world. You have to get things done. Like if I were sick, I would have to get my report cards done regardless, because you guys would be stranded. Like, what's the report card, right? If something happened to me, I would somehow have to figure it out regardless of what's going on. You guys would still need a report card, right? So I have to get things done regardless. This is like sort of life. You have to get things done regardless. Okay, push through. And obviously we can, if there is a bad thing happening, yes, but you still, if you just forget something, you just forgot it, or you just misread it, those aren't excuses enough to, like, let's not count things. That's not an excuse. Like, if I made a mistake, oh, I thought report cards were due on this day, and then wait a minute, I don't have anything done because I thought it was the wrong day for the report cards. I'm still screwed, right? So you guys have to understand that you got to meet those deadlines. This is sort of like real life for you guys. Okay. Okay. So that is it. I'm gonna let you guys go, and you guys got the rest of the day to work, finish up your unit 4 test. Okay. So I'll let you guys go. Have a good day, and I will talk to you guys tomorrow. Okay. Have a good day. Bye.
So,
Yeah.
for some of my quizzes, I wasn't
I
able
can't
to
hear you.
see them
Sorry,
Can you hear me now?
I can't hear you. Yep.
So for some of my quizzes, I wasn't able to see them, and then when I checked the actual like quiz tab because I didn't know there was one. Then it said I missed like 4, and I got a 0 for all of them.
Yeah, so what do you want me to do?
Is there any chance that like you can make them available? Or I'm
No,
not
you can't. You can't. You heard what I said, right? Like it doesn't work that way. You have. I don't know why you missed them. I don't know why you didn't see them, but they were always there. And in my Zoom, I always said there's a quiz. So either you must have missed the Zoom, which you don't have to go watch. You don't have to be. But if you watch the Zoom recordings, I would have said in the Zoom recordings there is a quiz. So something in your end that you didn't do is the reason why you missed it. And I can't do nothing about that. But it doesn't mean all is lost, right? Quizzes is
Yeah.
quizzes, right? You still have all, the unit 4 test, unit 3 test I didn't mark, and then we got unit 5 right now, and then we have the culminating. So all is not lost, but I can't do nothing about those quizzes. Don't worry about the quizzes, that's the past now. Worry what's in front of you.
All right.
Okay?
Thank you.
Okay, no problem. Bye.
Have a good day.
Bye.